G'day again. Welcome back to Mathematics 302. Hope you're having a good morning or a good evening. And I pray God blesses your studies, continuing to bless your studies. Okay, this is lecture 8, and this is part C. So in this part, we're going to look at power series, interval and radius of convergence, the root test, the limit test, and the ratio test. So in looking at these ones, I'm really going to just be giving you an example so you can see how they operate. Okay, so let's get into it. So the power series, if we look at a power series, an x minus c to the n, and we just expand that, we're going to get a to the 0, x minus c all to the 0, plus a to the 1, x minus c to the 1, plus a to the 2, x minus c to the 2, etc., etc., etc. So now what I want to do just quickly is compare that with a geometric series. So this is a typical geometric series. And the sum to infinity is a over 1 minus x. So you've got ax to the 0 plus ax to the 1 plus ax squared, and that will sum to infinity with a over 1 minus x. If the absolute value of x, just here, is less than 1, it converges. And the interval of convergence is between -1 and 1. Okay, so that's for a standard geometric series. We know that this is true. We also know that the radius of convergence is 1. That's because the center of convergence in this instance for this equation will be 0. So since it's going from there, the center of convergence will be 0. The radius is going from the center outwards, so 1 and 1, and that's the radius. So doing examples for power series, we're going to use the root test for this one. And there are, like I listed to start with, there's a few tests. We're just going to do 3 of them. So the root test, to determine the interval and radius of convergence. How do you know which test to use? Well, you look at the question and you think, yeah, it's obvious what test I should be using there. If you're given a question in a test, it will be telling you use this type of test. You can't get away with, I think I'll use this other test because it's easier. Yeah, well, probably not. You're going to be told use this test, and if you can't figure out how to do that test, that's not good. They're all fairly straightforward tests, so it won't be like, oh my goodness, I don't know what to do. It's pretty straightforward. So using the root test here, and this is the giveaway. You've got some equation to a really huge power. You're going to use the root test. So we're using this sum, and you've got this giant power. So let's suppose this was squared. You would take the square root of this whole thing. If this was cubed, you would take the cube root of this whole thing. This is to the n, so you're going to take the nth root of the whole thing. So the 1 over n of the whole thing. So what that means in terms of power is you're going to multiply each of these powers here by 1 over n. Very straightforward procedure. So 1 over n times 2n is 2. 1 over n times 1 is 1 over n. 1 over n times 3n is 3. And 1 over n times n is just 1, and I haven't put a 1 there. Don't really need it. So now we're going to take out 2x plus 17 because that's just a constant for the limit, because the limit is n approaching infinity. So we're only looking at this. I could also take out the 4 cubed and put that underneath. I didn't. And just for simplicity, I left it there, but I could have easily taken the 4 cubed out and put that over 4 cubed. But that's also just a constant. So this is what I'm really interested in, because the 4 cubed is just a number on the bottom, which we're not really interested in. So just in doing this example, I'm showing that this is the important part. So this will be infinite provided x is not equal to minus 17 on 2. So this n squared here, or n to the 2 plus 1 over n, will go to infinity as long as that's not true. And the series will diverge, because it's infinite, obviously. It will diverge for x not equal to minus 17 on 2. So therefore, it's divergence there. But once it's here, then it's going to converge. So the interval of convergence isn't really an interval in this instance. It's just the exact point. My image is going to get in the way of the next answer. The interval of convergence is going to be one single point. This is not rare because you can be given questions where this is the case. Okay, it looks rare. It doesn't happen that often, but it does happen where you're given questions, and it's not always where you do the root test to find this. It can be doing any sort of test where you find the interval of convergence is a single point, and you'll see that a bit later. Not that I've got single points coming up that often, but it can happen. So don't think, oh my goodness, I can't figure out the interval. Where you've got this one instance happening here, okay, that's going to be the interval. And the radius of convergence is going to be 0. It's not going to have a radius because you're on a single point. The radius is just 0. So not very common to do that when you're getting questions, but pay attention because it's likely to happen to you. Okay, so in this one, we're going to use the limit test. I use the limit test in part B, I think, of this lecture, where I use the limit test. The limit test, in my opinion, is the easiest way to determine the interval and radius of convergence. So obviously in a test, and you're not going to be able to use the limit test every single time because it just makes it too easy. You think, yeah, make it easy for us, Dr. Eric, please, please. Yeah. Well, no, you're intelligent people. You can face the challenge. Come on, yeah, let's go. Okay, so doing the limit test, you've got here the limit as x approaches infinity of this. You want to divide by the highest power in the denominator. So in this instance, x squared. So we're going to divide everything by x squared. So x divided by x squared, 2 divided by x squared, and 4x squared divided by x squared. So that will simplify quite easily. We've got 2 over x squared there. I've done it at an angle instead of having whole fractions over fractions. 1 over x, 2 over x squared minus 4. So this is really the only number that stays a number when x approaches infinity. This section here will go to 0. This section here will go to 0. So we'll have 0 over minus 4, which is 0. So the limit as x approaches infinity will be 0. And that is our center of convergence. So we haven't found the interval and the radius. By finding this limit, we've actually just found the center of convergence. So now to determine the interval, we're going to re-look at the equation. So what I've done here is I've just taken out the 2 because that's a constant. So we originally had 1x over 2 minus 4x squared. So I've just taken out the 2 here, the half, as a constant. So we're going to really look at this section here. Since x squared will always be positive, that's self-evident, then you can't get this going 1 minus 2x squared because there'll be no value here you can put in, obviously unless you put in I. Thank you. Yes, we know about unreal numbers, but here we're not doing that. We're putting in real numbers. This is always positive, so you can't get this to be a number which is greater than 1. So it will only converge if 2x squared is less than 1. And simplifying that, just using a really simple algebra, divide by 2, x squared is less than half, so x, take the square root, x is less than plus or minus 1 over root 2. And that is our interval. So our interval is going from minus 1 over root 2 to 1 over root 2. That is our interval of convergence. Now, you know you're getting that correct as long as you can see zeros in the middle and you're going the same distance on either way. And therefore, since that you're going 1 over root 2 that way, 1 over root 2 that way, in either direction, then 1 over root 2 is the radius of convergence. Okay, so hopefully that all makes sense. Ratio test, so the third one. So for any series where you've got the limit of un plus 1 over un, if you're getting it with L and it's less than 1, the series converges. If L is greater than 1, the series diverges. And if it equals 1, it may be divergent or convergent. And you might need to use a second test to figure it out. So if we use the ratio test on a power series and we get the following answers, if the result is 0, then it converges for all x values. The radius of convergence is infinity, and the interval is from minus infinity to infinity. If the result is infinity, then it diverges for all x values. It only converges for x equal to c, and the radius of convergence is 0. And the interval is c itself. If the result is less than 1 for some expression here, then multiply both sides by r, and so you get x minus c is less than r. The radius of convergence is r, and the interval is minus r plus c to r plus c. So having said all that, let's do an example. So that's just sort of background information before using the ratio test. So determine whether the following series converge or diverge. So we're just going to look at that. We're going to use the ratio test. So the ratio test is just we're going to use n plus 1 and n. So we want to figure out what is n plus 1. So we're just going to put n plus 1 there, there, and there. So, and now we're going to simplify it. So we're going to get minus 10 to the n plus 1, 4 to the 2n plus 3, multiplied by n plus 2. So all we've done here is we've got a to the n, which is the question, and we just put in n plus 1 wherever there's an n. So n plus 1, n plus 1, n plus 1, n plus 1. I could have put that in brackets if I wanted. And now I've just simplified it. So the n plus 1 is still n plus 1 up here for the minus 10. N plus 1 plus 1 is going to be, so we're going to 2 n plus 1 plus 1, so 2 n's. 2 times 1 is 2, plus another one is 3, and n plus 1 plus 1 is n plus 2. So that's just simplified. So now we've got our an and our an plus 1. Now we can use the ratio test. So the ratio test is the limit as n approaches infinity of un plus 1 over un. So we're going to put this over the top of this, which will be a fraction over the fraction. So a fraction divided by a fraction, you can multiply by flipping. So we're going to flip the u to the power of n, which is this one. We're going to turn it upside down. So we will get this. Limit of n approaches infinity of, and here we've got the n plus 1 section, and here we've got the n section. Okay, so we've just flipped this bit upside down. So we multiplied, and that's a multiply sign, not an x. So multiplied by this upside down. So basic fraction. I don't know what year you learned that in. Flip the fraction, flip the fraction, flip the fraction upside down. Okay. And so here you're going to cancel a lot of things. So we've got minus 10 to the n and minus 10 to the n plus 1. So that 10 to the n will cancel with that, and you'll just end up with minus 10 on top. The 4 will cancel here. You've got 2 to the n, 2 to the n plus 3, and you've got n plus 1 here and n plus 2. So the n plus 1 and the n plus 2 stay there. The minus 10 just becomes minus 10, and you'll end up here just with 4 squared. So 2n will cancel. You've got cubed here and a single number here, so that becomes 4 squared. So now this is a lot simpler to deal with as n approaches infinity. As n approaches infinity, we can take out minus 10 over 16 for this. So this is now a constant. And we can, now look at that constant and say, well, that constant there is less than 1, therefore it converges. Okay. So that's using the ratio test. We've got that less than 1, and just like we went through those reasonings before, that converges. And there are a lot of other questions you could do there in Lemma. Okay, thank you for that. I'll see you in part D, and there'll be hopefully a lot more questions that I can create for you to do. Okay, God bless you. Stay safe. Bye.